Hi everybody, it's Mrs. Gifford here, and we're going to continue our work with solving equations. With today's lesson, we're going to add or put variables on both sides of the equal sign and work on solving equations that way. So after this, you will be able to solve equations when there's variables on both sides. So let's just get right into our examples. Again, here's those 5-step reminders that we had with the previous lesson. No need to rewrite these all, but maybe you should have these other notes out handy just to remind you of those 5 steps. So let's look at our first equation. 4k minus 3 equals 2k plus 5. So we're going to write that out. There isn't anything for me to simplify on both sides of those equal signs, but we do want to move the variable to one side of the equation. So right now, I'm going to take that 2k and I'm going to subtract it. The reason why we're subtracting it is because it's a positive, and the only way to get that to cancel is it needs to be its opposite. So the 2k's are going to cancel, and then 4k minus 2k gives us 2k. 4 minus 2 is 2. Keep that variable the same. And then we didn't do anything with this minus 3, so that has to come down also. And then after canceling those k's, we're going to bring that 5 down. Now this equation should look very similar to the problems in the previous lesson. So again, our goal is going to be to get k to be all by itself. Since we have the k's over here on the left-hand side, that means we need to do something with that negative 3. And to undo minus 3, or that subtraction of 3, we're going to add 3 to both sides. Again, the reason why we do that is to get it to cancel, because we want to bring or solve for k. And I'm going to bring that down. And I've got 2k on the left side equals 5 plus 3 is equal to 8. And I want this k to be alone, so again I'm going to divide by 2. 2 divided by 2 is 1k, and 8 divided by 2 is 4. Now, one thing I want you to notice, and I didn't do this right away because I wanted to keep the shield, but we have this line straight down. I try to keep the equal signs stacked up on top of each other just to keep everything in balance. Also, what we've already talked about a few times is take this answer and plug it back into the original equation. So I'm going to see if 4 times 4 minus 3 really is equal to 2 times 4 plus 5. So I like to write it out, and then I also like to make sure I write down those steps. 4 times 4 is 16. That gives me 13 equals 2 times 4 is 8. And 8 plus 5 is also 13. So I know that we did this problem correctly. Example number 2, I have 3a plus 3 minus 5 equals 3a minus 2. And again, we're going to follow those 5 steps. Draw your balance line. We're going to simplify both sides. Well, if you look carefully, there's something right here that we can simplify with our 3a minus 5. So I did that. Notice my 3a's are the same. 3 minus 5 gives me negative 2. Here's my equal sign, and then I still have 3a minus 2. So again, the goal is to get the variables on one side of the equation, so I'm going to subtract 3a from both sides. And as we've already talked about, when we do that, that cancels the 3a here. I'm going to bring my negative 2 down. My 3a's are also canceled on this right-hand side, and I'm going to bring this negative 2 down. So I get negative 2 equals negative 2. And thinking back to what you learned last year, do you remember what we call this when we get the same number on either sides? If you are thinking that the solution is all real numbers, you are absolutely correct. Basically what that means is you can pick any number in the real number categories that would make this true. So I'm just going to pick the number 1 to plug in this equation. And like I said, you can pick any number that you want. Once you get here, just to double check. So I'm going to do 3 times 1 plus 3 minus 5. 3 times 1 is 3 plus 3 minus 5. 3 plus 3 is 6 minus 5 is 1. If we did this correctly and I take a 1 and put it here in place of the a, if I do it correctly and I plug it in, I should get a 1 also. So 3 times 1 minus 2, 3 minus 2 does equal 1. So because we got the same answer here and here, we know that all real numbers is the correct solution for that one. Now, just one point of clarification, some of you may have noticed at this point right here that you had the exact same thing on both sides of the equal sign. You know what, as long as you recognize that it's exactly the same, you could stop here and be done with it and say that your solution is all real numbers. All right, on to the next one. This one's just a titch more complicated. One thing you should see here is that there's parentheses. So we've also talked about this already, but we need to simplify this by distributing. And so we're going to give that 2 to everything inside the parentheses here on the left, and we're going to give that 4 to everything inside the parentheses here on the right. When we do that, we get 2w minus 2 plus 4 equals 4w plus 4. And then going back to those 5 steps, we want to simplify the left-hand side of this equation. So I get that. Negative 2 plus 4 is 2. Notice I'm bringing down everything that I haven't used yet from one step to the next, just to make sure I'm not losing any of my parts of my equations. So then, now this looks like the previous example, so the goal is to get all the variables on one side. Again, we're going to try and subtract the smaller one, just to kind of keep it concrete. 2w minus 2w, those guys cancel. I'm going to bring my 2 down. 4w minus 2w, and I'm also going to bring this 4 down. 4w minus 2w is 2w. Here's the w all by itself, so we need to get rid of that plus 4 by subtracting it. 2 minus 4 is negative 2. And again, bring your 2w down, and then my last step is to divide by 2. Those 2's cancel, leave us with w. W equals negative 1. If you need to think of it this way, you could flip it around and say w equals negative 1 this way as well. So again, we're going to check that answer, and just like the previous ones, we're going to take negative 1 and we're going to put it in place of where our w was in the original equation. We're going to look to see if these really are true. Move my little question mark guy there. So first thing I'm going to do, inside the parentheses, I get a negative 2. Negative 1 plus 1 is 0. And 2 times negative 2 is negative 4, and add them together we get 4. So we know in this case, because I got down to the same number on both sides of the equal sign, that what we did was correct. If you had gotten to this point and you had like 7 equals 0, then you know that your solution back here is not correct. All right, example number 4. So we have negative 4 times the quantity of r plus 2 equals 4 times the quantity of 2 minus 4r. Just like before, the first thing that we need to do is distribute that negative 4 into the parentheses, and the same thing on the right-hand side. When we do that, we get negative 4r minus 8 equals 8 minus 16r. Now, it's exactly like the previous examples, so we aim to get all the r's on one side, the plain numbers on the other, and figure out what r equals. In this case, I'm choosing to add 4 to both sides, or excuse me, 4r. That gets these to cancel. It leaves me with my negative 8. I have not used my 8, and negative 16 plus 4 is negative 12. Again, here's my line straight through my equal sign. And now I need to move this positive 8, and we do that by subtracting. Again, we're going to do that to get rid of this 8 on the right-hand side. We need to bring down our negative 12r. Be very careful. This negative, for some reason, some people forget about this negative sign here, so make sure that you bring that down with it as well. Negative 8 minus 8 is negative 16. Bring that negative 12r down like I said, and then when you get to this point, divide by negative 12. And in this case, we get a fraction, 1 1/3, 1.3 repeating. And actually, I'm going to use the improper fraction of 4/3 as I check this, just to make sure that what we've done is correct again. So I've changed my mixed number into an improper, and I put it in place here. Now, when you get to this point, feel free to use the calculators to do so. So I have my graphing calculator here, and I'm just going to type this in, and the first thing I'm going to do is negative 4 times, and now anytime we enter a fraction into the calculator, we need to make sure we put it inside parentheses as well. So I'm going to put a second set of parentheses and close it off. So this represents my 4/3, and then I need to do plus 2, and I'm going to close that off and hit equals. And so I know that that's, whoops, where'd my calculator go? I know that's going to be negative 13.3 repeating. So I'm going to write that here, negative 13.3 repeating. Again, there's my negative 4 times the 4/3 plus 2. And now I'm going to put the stuff over here on the right-hand side, and I'm going to do that the same. So I'm going to do 4 times 2 minus 4. And because I have a fraction, I'm going to put parentheses, 4 divided by 3. The first parentheses for the fraction, the second parentheses for the parentheses here. And I'm going to hit enter. And I get negative 13.3 also. So I know, again, that my answers are correct and my solution is good. So let's take a quick minute or a couple minutes to write our summary for this lesson. What was the focus of today's lesson? I learned or remembered. An example is, and I have a question about. Again, when you make up an example in there, when you talk about your example for your summary, you should make sure that your example is one that you've made up yourself. So there you have it, folks, just continuing our conversation on solving equations. Have a good one.